Welcome to educator.com. This lesson is about writing inequalities. In this lesson, you will learn to write and test inequalities. Applications are for describing minimum and maximum quantities. Vocabulary. An inequality is a mathematical sentence that contains either a less than, greater than, less than or equal to, or greater than or equal to symbol. A way that you can remember how to read these symbols is to always read the left side. So, for example, this is called less than, since the left side is closed, indicating a small amount. This is called greater than, since the left side is open, indicating a larger amount. This is called less than or equal to, because we have the less than symbol above and then half of an equal sign. And then to the left here, the mouth is open. You could think about it as the alligator mouth, which you probably learned about that in elementary school, always wanting to eat the greater quantity. So the left side here is open and it's greater than or equal to, because the bottom has half an equal sign. And we'll be using those inequalities, and you can understand better what the less than or equal to and greater than or equal to means. A system of inequalities is two or more inequalities together used to describe some real-world situations. Oftentimes when you have a system of inequalities, it's to describe the minimum amount all the way up to the maximum amount. And so it's the amount included between the minimum and the maximum. The solution of an inequality is any number that would make the inequality true. So for example, if I wanted someone to bring at least 5 cookies to the party and they brought 6, that would be a solution because they have brought at least 5. They've brought the necessary minimum amount. Writing an inequality. So in this lesson, we need to translate the words, the verbal description, into inequalities. Write an inequality for the verbal description, the price P is more than $6, and graph. So we have a price P and we have $6 and it's more than. So P is more than, greater than 6. It doesn't say that it can equal 6, it says that it's greater than 6. And on a number line, we could create, you want to put 6 somewhere in the middle. Just create a normal number line. And P, you put the circle around the 6, you put the circle around the value you're discussing, and P is everything greater. So which side do the numbers get greater? To the right. 7 would be greater than 6, that would work. 8 would be greater than 6, that would work. And every value after. So I'm going to color in the left side. And note that I'm also going to color in the arrow, because by coloring in the arrow, I'm indicating that every number after 8 is also a solution. Notice that I've left the circle at 6 open because 6 is not a solution. The areas that are colored in represent solutions. Notice that even 6.5 has been colored in because 6.5 is also greater than 6. So the open circle around 6 indicates that does not include 6, but everything colored into the right says everything greater is greater to the right. Write an inequality for the verbal description, a wage W is at least $8.25 and graph. So we have a wage of W and an amount of $8.25. W and $8.25. Now with the words at least, that can be a little confusing. So let's think about what that means. That means that at the very minimum, at the very least, it's $8.25. So it could be more than $8.25. So W could be more than $8.25. But it's also saying at the very least, meaning it could also include $8.25. The amount that you could be earning could be $8.25, or it could be more. So W is greater than or equal to $8.25. So make note that the words at least mean greater than or equal to. And let's also graph it now. So I'm going to put 8, 9, and 7. And I've separated it so that I can indicate the decimal. So 8.25 is about 1/4 of the way in. And I'm going to put the circle around it. And this time we've agreed that it could equal 825. So I'm going to color in the circle. And then we've decided it's everything larger than 825, including 825. So I'm going to color in all the amounts to the right, which indicate larger values. And I'm also going to color in the arrow because those larger values could go on to infinity. Writing a system of inequalities. Remember that a system of inequalities is two or more inequalities. During a recent storm, the wind speed was greater than 55 miles an hour, but less than 78 miles an hour. Write a system of inequalities to represent this situation. So the wind speed was greater. Let's call that S for wind speed. The wind speed was greater than 55 miles. However, it was also less than 78 miles. So here I've created a system of inequalities because I have two inequalities, two parameters. It's telling me that 55 is S is greater than 55, but also that S cannot be greater than 78. So here I've combined it. If you're writing the two inequalities together, the system of inequalities together, make sure that your signs are following the same direction. Notice the closed end is touching 55. And once again, I have the closed end touching 55. Here the open end is facing the 78, so also the open end is facing the 78. And it makes sense because the speed falls in between these two values. 55 is at the lowest and 78 is at the highest. Now let's graph this. So if I put 78 here, 77, 76, 75, 74, 73. So I'm noticing that by going by ones, this is probably not the best idea, so I'm going to redo it. When you're graphing, you may try your graph a few times to find which will give you the best visual representation and is also easy for you to draw. So I'm thinking that if I count by twos here, that might be a lot easier for me. So I'm going to say 78, 76, 74, 72, 70, 68, 66. It might have even been a good idea to count by fives, but I can do this with this by the twos because I have plenty of room here. 64. It might depend on how much room you have on your paper. And of course, it's always a good idea to do graphs on graph paper. 58, 56, 54. And I can stop here. So 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, and 80, and then I can stop there. So my greatest value is at 78, but not including 78, so my circle's open. And my smallest value is at 55, which I'm going to draw in here, but not including 55, so my circle is open. And then the wind speed can be anything in between these two values. So I'm going to color in everything in between these two values. So once again, to keep your graph looking neat and professional, graph paper is very helpful. Sometimes you could also use a marker for this, but you want to make sure that you're not going to be changing your graph if you use something that you can't erase. And so your greatest speed, once again, is at 78 with an open circle since it's not including 78, and at the lowest speed of 55. And you might want to say miles per hour here, since it is a word problem and we want to include our units. A price of a room in Las Vegas is at least $85, but at most $350. So this is a little different in our last problem because it's saying it's at least $85, meaning it can include $85. So at the low end, we have $85, which it could equal the room price. And at the most, it could also equal is $350. So different than the last example now, we have the fact that they could also equal. And R falls in between the lowest and the largest value. So to graph this, I'm going to graph by 50s. 50, 100, 150, 200, 250, 300, 350, and 400. All right, so my lowest value is at 85. You'll have to estimate that on your graph about here. And I'm going to color in my circle this time because it can equal $85. And then my largest value is at $35, which I'm also going to color in because the room could be $35. And then there are rates anywhere in between. So I'm going to color in everything in between. Identifying solutions of an inequality. You must be at least 16 years old to get a driver's permit. Write an inequality and use it to determine which students listed in the table can apply. So at the very least, you have to be 16 years old. You can be more than 16, or you could in fact even be just 16, but you have to be at least 16 or more. So the age is, I'm going to say A for age, should be greater than, but it could also equal 16. So now we've been given 3 people and their ages, and let's check which are true. So I'm going to start with the first one. Is 16 and a half larger than or equal to 16? Yes, it is. It's larger than 16. So this holds true. This inequality holds true. 15 and a half is larger than or equal to 16? No, that's not true. So let's write false. That is not a solution. And lastly, 17 is greater than or equal to 16? Yes, that's true. So we've found the 2 solutions that will work for this inequality. And we've determined that the students are going to be John and Heather. And the other part that the problem asked for was for us to write an inequality. And here is our inequality. And then we've determined the students as John and Heather. Write an inequality for the verbal description, a number x is not positive. Graph the inequality. So here we have to think about what a positive number is. A positive number is any number greater than 0. However, it doesn't include 0. 0 is a funny number. It's not positive or negative. So we know that 0 is our turning point, however. Anything below it becomes negative and anything above it is positive. So we have a number x, and we know that there's going to be some type of symbol dealing with 0. Well, if it's not positive, it means that we want x to be a negative value. So x has to be smaller than 0. X is going to be everything smaller than 0, but not including 0. So now let's graph the inequality, which is easy with 0. You can just show a couple above and below. So an open circle around 0, and I'm going to leave it open, indicating that it cannot equal 0. And then I'm going to color everything to the left, everything in the negative portion, because it's telling me that x is everything that is negative. Notice that I've also completely colored in the arrow because the arrow indicates that it goes on for infinity, every value below -1, even though it has not been shown on the graph. Write a system of inequalities for this situation. The temperature should be less than 80 degrees Fahrenheit, but at least 65 degrees Fahrenheit. So it needs to be less than 80 degrees, the temperature, but it can at least be 65. Well, that means it can equal 65 degrees. So it's got to be greater than 65 or at least equal to it. So it could equal. So notice in our system of operations here, we have 2 different types of inequality symbols. The temperature's got to be greater than 65, but it could also equal 65. And the temperature must be lower than 80. Let's graph this solution. I'm going to graph it using 5 intervals. So I'm going to start with 60, 65, 70, 75, and 80, and just to finish up the graph, 85, 90. All right, so I have a circle around 65, and this time my circle is going to be colored in because it's telling me that the temperature can also be 65. But the temperature has to be lower than 80. It can't even reach 80. It's got to be lower than 80. So my circle stays open because it can't be 80. But it can be everything in between. So I'm going to color in everything in between the 80 and the 65. And the 65 is also colored in because it also equals 65. Write an inequality for 5 is less than 8 more than a number. 5 is less than 8 more than a number. So we're looking at 5, less than is our symbol, and then 8 more than a number is the other side of our inequality. So 5 is less than 8 more than a number. So we have a number represented by n. 8 more than that is 8. Notice this is not saying 8 is greater than a number. It's saying 8 more than a number. So you take a number and give it 8 more, add 8, and 5 is going to be less than that. Write and use an inequality to solve the problem. A child must be at least 3 feet 10 inches to ride the roller coaster. Use the table to identify the children that can ride the roller coaster. So let's first write our inequality, and then we'll plug in each of these values and see if they hold true. So the child in height, I'm going to say H for height, must be at least. So that means it could also be 3 feet and 10 inches. It could be more than 3 feet and 10 inches, or it could just simply be 3 feet and 10 inches. And those are our parameters. It has to at least hit 3 feet and 10 inches, but it could be anything more than that. So now let's see who that holds true for. 3 feet 11 inches is, oh, it's telling us the height has to be greater than, sorry, we're switching it. The height has to be greater. The child has to be taller than 3 feet and 10 inches. So at least 3 feet and 10 inches. And now let's see which one works out here. 3 feet and 11 inches, yes, that holds true. 4 feet and 2 inches, yes, that's still greater than 3 feet and 10 inches. 3 feet 8 inches, false. This person is not tall enough. 4 feet, yes, that's taller. And 3 feet 7 inches, false, not taller. So the height, at the very least, at the minimum, at the lowest point, had to be 3 feet 10 inches. But then it could be anything above. So notice that anything above. So this is greater. So this is saying that H, the height, has to be greater or at least equal to it. So use the table to identify the children. The children are Josie, Charlie, and Jeremy. These 3 children can ride the roller coaster. Thank you for watching educator.com.